Okay, so now we're going to continue on building our linked list in Java by implementing our iterator. So iterator is a method within the class that returns an object of type iterator. And so we're going to have to build our own class that implements iterator in order to do this. So iterator returns an iterator over the elements of this list in proper sequence. And so that iterator object is what we're going to have to make. And that iterator basically enables us to repeatedly call this next method and get the next element in the list each time. So each time you call next, you'll get a new element. hasNext will tell you if there's still another element left in the list, and remove will remove the last element that was just returned by next. So let's take a look at an example of how that would work. If we had a list and we added a bunch of stuff to our list, then what we can do is call list.iterator, and this will give us an iterator object. And this iterator, we can call next on it, and the first time we call next, we should expect it will give us 1, and the second time we call next, it should be 2, because that's what the first and second element in the list are. So each time you call next, you get the next element. Now hasNext tells you whether there still is another element. So if we called hasNext at this point, we would get true, because there's still a 3 and a 4 left that we haven't iterated through yet. So that would be true. Whereas if we did iter.next again, that would give us a 3. Iter.next again, that would give us a 4. And now if we called iter.hasNext, we should get false, because there's nothing else left in the list to get when we call next. And actually, if we called next again, we should get an exception. As you can see by looking at the next, if you call next when there's no more elements, then you get this no such element exception. And then there's also the remove method, which removes the element that you just got back from the previous next call. So like if we called iter.remove at this point, then now there should be no more 4 in our list, basically. But it doesn't actually return anything, so actually the size of our list would then be 3 instead of 4. And then also the iterator enables us to use a for each loop to loop through our list. So if we just put our list here, this syntax implicitly uses our iterator method to get an iterator for this list, and then it uses our next method to continually get more elements out of the list until we no longer have any elements in the list. And that for each loop just assigns this s variable on each iteration to the next element in the loop. So in this case, this would loop through everything in the list and print out each of the elements. And this is only possible if you actually implement the iterator method and your class implements iterable, which linked list, the list interface already implements iterable, so we don't actually have to write iterable here. Okay, so now let's get started and implement this. So we can see our iterator method here. Where did it go? It is right here. Okay, so iterator. What we're going to want to do with this is we're going to return a new linked list iterator. And what is a linked list iterator is what we're going to have to implement now. So we're going to have to make this class called linked list iterator, which we can do here, class linked list iterator implements iterator. And now within this class, we're going to have to first add a constructor here. So I'll write public linked list iterator, and we'll just leave it taking no arguments. And what we're going to have to do is set up a current node variable that will keep track of where this iterator currently is within our list. So I'm going to make a private node E called current, and then in our constructor we're going to set current equal to head. That way our current starts off right at the beginning of our list. So let's start by looking at implementing our hasNext. Actually, no, let's start with our next method. So that's going to be public e next. And we can check our documentation here to make sure this is right. Returns a e, and it's called next. Returns the next element in the iteration, and it returns it throws a no such element exception if the iteration has no more elements. Okay, so when does the iteration have no more elements? If our current equals null, that will mean that there's no more elements in the list. So we're going to throw new no such element exception, and that's just to follow this right here. Okay, so now that we've done that, what we want to do is we really want to return current dot get data. So that's going to return the element that the data that's inside of our current element, which is inside of our current node, which is the actual element in the list. But what we also want to do here is set current so that now it's pointing at the next item in the list. That way, next time next gets called, we're at the next element. So in order to do that, what we're going to do is we got to advance current equal to current dot get next. But now you can see we have an issue because this actual data that we're returning is not the actual element that we want to return, because now current is the next element. So we're going to have to save this element in a temporary variable so that we can return it right here. So now before we advance current to the next element, the next node, we save that data. That way, after we advance it, then we can return the actual data that's at current. So that looks like we've got a pretty good implementation of next. Now let's check out hasNext. So public boolean hasNext. We can check that in our documentation. It's boolean hasNext returns true if the iteration has no more elements. In other words, returns true if next would return an element rather than throwing an exception. So I guess all we're going to have to do for this is say it has a next one as long as current does not equal null. Because if current equals null, that means there's no more elements to return for next. Okay, so now that we've got next and hasNext implemented, let's think about how we can implement remove. This one's going to be a little bit trickier. So remove removes from the underlying collection the last element returned by this iterator. The method can be called only once per call to next. The behavior of an iterator is unspecified if the collection is modified while the iteration is in process in any way other than by calling this method. Okay, so let's write out that method here. Public void remove, and it's going to remove whatever element we just got out of our next method. So in order to do that, we're going to have to actually know what element we just returned out of our next method. So to make this work, we're going to have to actually save what the previous node was. So I'm going to add another node to our class as an instance variable. And before we overwrite current with the next one, I'm going to set previous equal to current. So now we know which node we have to remove from the list. So when we call remove, we know that it's previous is the one that we want to remove. But in order to remove previous, what's going to happen is we actually have to know what node is before previous, because the node before previous is pointing to previous, and we don't want it to point there anymore since previous is no longer be in the list. We want previous, the node before previous, to point to current, so that the node called previous gets skipped over in our list now since we're removing it. So what we're going to have to do in order to do that is we have to keep track of what the node before previous was in our list. So what I'm going to do is I'm going to add a third variable up here called previous2, and this will be the node that's before previous. And we're going to have to update that in our next method also. So previous2 becomes previous, and then previous becomes current, and current becomes the node after current. So now previous2 is the node before previous, and previous is the node before current. And so in our remove method, what we are going to have to do is actually remove that previous node. And in order to do that, there are a couple special cases we have to think about. So if you call remove right when right after you make the iterator, before next has ever been called, then we can see that that is supposed to return an illegal state exception if next method has not been called. So let's deal with that first. So how do we know that next has not been called? Well, let's initialize previous to null and previous2 to null. And so now we know if previous is null, that means next has never been called, because previous is still at null, which is what it's defined as in the constructor. So if previous is null, then we're going to throw new illegal state exception. And then what if previous2 is null? So if previous2 is null, that means that we've called next once. So the node that we're trying to remove, previous, is actually the first node in the list. So if we're removing the first node in the list, what we're going to have to do is set head equal to current. That way the head of our list is now the current node, and the previous node has been skipped over. And so we have a new front of our list. And now the last case is previous2 is not null, so previous2, we want the next node after previous2 to now be current. That way we're skipping over that node that we're trying to remove. And then of course we want to decrement the size of our list since we've just removed something. And that looks like an implementation of remove that we think will work. So let's go back and look at our documentation again. It removes from the underlying collection the last element returned by this iterator. So that sounds like what we have. Now let's look at these exceptions. We return an illegal state exception if the next method has not been called or the remove method has already been called after the last call to next. So this is basically if you call remove twice with no next call in between. So this sounds like it might be a little bit of a tricky case to deal with. So what we're going to have to do here is we need to keep track whether we've called next since our last remove. So I'm going to keep another instance variable here that's a boolean called remove called. And I'm going to initialize remove called to equal false. And now every time we call remove, I'm going to set remove called equal to true. And then up here, if our previous is null or we already called remove, then we want to throw this illegal state exception. And now after we call next, we're going to set remove called back to false. That way remove can be called again one more time after after that call to next. So that looks like we've got a good implementation for our methods here, for our iterator. And now let's test and see if it works correctly. So we're going to go back to our main system.out.println. I'm going to add that to each of these calls. That way we can actually tell if these are printing out what we think they should be printing out. This remove actually doesn't return anything, so that's not going to be useful here, but the rest of these okay. So now let's run this. Oh, looks like we have some issues here. Oh, this is not supposed to be an E, this is an iterator over strings. Okay, so let's see what we got. We got a 1, 1, 2, true, 3, 4, false, and then a 1, 2, 3. So that looks like what we expected to get since we wrote it out here. 1, 2 for our calls to next, and then true because there's still more elements left. 3, 4. Remove, this should remove 4 from the list. hasNext should now be false because there's nothing else left to iterate through in the list. And here we're printing out everything in the list, and we see 1, 2, 3. There's no more 4 there because we removed it with our remove method. So that looks like we've got it working correctly. Let's try out some other cases here. iter.remove, if we put it right there, what should we get? We should get the illegal state exception because next has not been called yet, so let's test that. Oh, awesome, so we got illegal state exception. How about if we remove the first element in the list, like right here? Okay, now You see at the end we're just printing out 2 and 3 because both 1 and 2 or 1 and 4 were removed from the list. So it looks like our iterator is working great. So that concludes this video. One more test to add on to this video that I forgot previously is trying 2 removes right in a row on 2 elements. If we run this, you'll see we actually don't get the correct output here. We still have a 2 and a 4 in the list when we should have removed that 4 from the list by this remove call right here. So it looks like we have a bug here. So if we go back into our linked list code, you'll see in our remove method, when we set the next of previous to current, we neglected to update what our previous was set as. So now that we've removed the previous node, what we're going to need to do is update our previous to be actually what previous to is, because now previous to is the node before current. And that should fix our bug. We actually don't have to update previous to, because previous to will get overwritten right away in our next call to next. But this should fix that bug in our code. So if we run it again, we'll see now we only have 2. So that should be good for our implementation of our linked list iterator.